got a ceiling fan. There's the lights. There's the ceiling fan motor. The lights work, but the motor doesn't. So we need to try to figure out what's going on with that. So here, I'm going to plug it in right now. I have our power wires right here to the red, or the black and the white of the motor. The blue is just for the lights. I'm not going to connect that up because I don't care about the lights. I'm going to hold this, just set it on the end, because if this was to start up, this would start spinning, but it's not gonna, because that's what I'm going to show you. So I'm going to plug it in. There, it's plugged in, and the little pull cord is right here. I don't know where it's at right now, but I can pull it. There's one, there's two, three, and off maybe. I don't know. I don't know where it's sitting in there. But you can see this didn't move at all, no matter what. So we need to figure out why. And that's going to begin right now. So the first thing we're going to do, we'll get rid of this motor part, because we don't really need that for what we're doing right now. Because the first thing we should do is check and see if the switch is working, because that's easier to get to than the motor if there's something wrong with that. And the capacitor we should check also. So we'll check the switch, the capacitor, and there is a switch here that reverses the fan from blowing up or down. Not a whole lot can go wrong with that, but so we're not really gonna pay attention to that right now. So first thing we need to do is we need to take this little nut off here that holds the switch in there. This way we can get to the switch, the little holes here, and check the capacitor easier too. Now for me, I would rather take this apart, take the wires out of here, and then check it so it's not connected to the capacitor, because you'll get different readings, I'm sure. So I'm going to put my meter on capacitance. We can try it and see what we get. The black is the common to all the other ones. So the black actually comes in right from like the wall. So these are also labeled. There's a 1 for the gray, 2 for the brown, 3 for the green, and L for the black. And assuming that is load. So our load comes in, and then it switches between these three here. So I'll just put my black probe in there, and then we'll see what we get when we stick it in here. Nothing in that one, nothing in number 3. Oops, what did I do? I put that on the wrong. I was thinking capacitance because of the capacitor, but I put it on ohms, and we'll do a beep and see if that works for us. Brain fart 1 already. Just started the video. So we'll check that. Nothing. We'll check the gray. Nothing. And we'll check the brown. Nothing. Make sure I have that in there correctly. Alright, so none of them read. So let's pull the switch one time, because we have off, slow, medium, and fast. So we got 4 different positions. So in this one, there's still nothing. We'll stick it in number 1. Oh, number 1 has something. Let's go over to 3. 3 has nothing. And of course we did 2, so 2 has nothing. So I'm going to leave that in 2, and when I pull this, we should have continuity now through there. because it's going to run the black wire power, which our negative probe is connected to, through the switch and out our number 2. And there it goes. So far that's good. Now let's put this in number 3, because our next pole would be number 3. And 2 and 3 are connected, and that has something to do with the way the motor works. But even if you take this apart, you're going to get a connection between 2 and 3. So let me pull this for the 3rd time, and you can see it still stays connected. Now, I don't know exactly how they have the windings in here, but 2 and 3 work together to make the motor spin at the appropriate speed and uses the capacitance that way. So I'm going to pull it one more time, and now that's off. So now nothing has continuity. So right there tells us that this switch is good, because it worked in all 3 spots. Now let's take this apart and examine if 2 and 3 are connected without it. I don't remember back from my other video, but I think these 2 will still be connected together without all the wires in there. So to take these wires out, there's a little piece of metal in there, and on this one, they're all like on the inside right here. So the metal goes across here. So we're going to stick our little pin in there and then push away from the metal just slightly, and then that pulls the wire out. You don't have to really push hard or anything. And then we'll do the same here. And that comes out. Do the same here. So you stick it in and push towards the wire. Get that in there right. And then the wire comes out. So stick it in, push towards the wire a little bit, and the wire comes out. So now let's answer your curiosity. Okay, remember nothing's connected right now because we stopped when it was in the off position. So we got to put this negative in our load. This was 2 and 3. And it showed that it didn't matter if it was set on 2 or 3, both of these were connected together. So the first pole is going to be is number 1. So we should get continuity right here. Okay, that's continuity for the number 1. So now if we stick it in 2 and 3, it's not going to read anything. Okay, so now let's go to 2. Let's just let that set in there, and let's pull this again. And now we should have continuity. There we go. So we have continuity on 2. Now let's stick it in 3. See, we have continuity there. So this switch on the inside is made so it connects 2 and 3 no matter what position it's in. When you're in 2 and 3, that's all about getting the motor to spin at the right speed. So we pull this again, and it should still stay continuity because it's on 3 now, and that's 3. So the beeping noise is annoying, so let's pull it the 4th time and turn it off, and there it's off. So that's the proper way that the switch should work. So we know we're done with this because that works fine. All right, so now let's check the capacitor. It's probably real hard to read the values on there, so I'll take a little picture and stick it up in the corner. But this, it says from the gray wire, which is right here, either of the gray wires coming out of this back, because they're actually connected together on this side. So we'll use this gray wire and go to the red wire, which is this red wire, and we're going to trace that back into here. that should be 4 microfarads. And then we're going to go from the gray to the green, this wire here, which is our connection right here. That should be 4 microfarads. And then the gray to the brown that comes out of here, which is right here, that was in our switch, that should be 2.5 microfarads. Okay, so let's measure those. Let's put my meter on capacitance. There we go. And now we'll touch the gray one, because that's on one side of the capacitor. And since we got the green and the brown out here, let's just check those first. So the brown said it was 2.5 microfarads. Look at the meter, and we got 2.5 microfarads. Okay, that's good. Let's go to green, so we'll leave it on the gray and we'll check the green. Look at the meter. And that says 4.05 microfarads. That's exactly what it's supposed to be, 4 microfarads. Now, let me find the red. Here's the red. This wire right here, it's in the corner, so I'm just going to stick this right down in there so you can touch it. And then I'm going to touch our gray, and we look at the meter, and we have 4.01 microfarads. So the capacitor reads good. That's good. If it read a little high or a little low, it would probably still be good, but if it didn't read close to them numbers, then yeah, it's probably bad. So we're doing good so far. So our switch is good, our capacitor is good. So let me throw this back together. So remember the picture we took, or if you got a good memory, and sometimes these, they look like they're already set in the places where we can just stick them in there. So we had the gray for number 1, and they just push right in there. The green for number 2, and you can see that there's a piece of metal in there. Let's turn that off. The leads were touching. We'll just push that in there. And then the black, which is the load. Which is a little short for some reason. Push that in there. That's in there. And now the brown, which is way back here. And now that's in there. Now let's pull our little nut up there, and we'll stick this right through there again to secure it. There we go. And they got two-way sticky tape on here. That ain't too sticky anymore. And I'm sure that was somewhere down here, just out of the way. You can, it doesn't matter as long as it's out of the way. So if we wanted to check this switch right here, we have, you can see we have a pink, a gray, a yellow, and a white. So we would have to find those ends. So let's look for a gray and a white. Maybe, let's see, let's pick the right ones in this connector. Okay, let's look for the pink and the yellow. So there's our yellow. Our pink should be right on the opposite side of it. So if we put our meter in them, pull that out there, go back over here in ohms, put on our continuity. So if we put this in the yellow and the pink, we should get continuity if we flip this switch one way or the other. No, that's the two separate switches. Where's the white? I'm on the pink on one side, and that's on the bottom of the switch. So I'm going to look for the white that's on the bottom of the other side of the switch. So that white, where is that white? That white is right here in the middle. Right here. So there we have continuity there. So if we flip this switch, we have no continuity. So that tells us half our switch is good. Okay, so let's measure the other half of the switch, which is going to be the gray wire and the yellow wire. So let's find where the gray wire is going. And the gray wire happens to be going right into the capacitor. So we're going to have to cheat and use the gray of the switch. Remember I said they're both connected together. So I'm going to take this switch back out, and this is our gray here, so I'm going to stick one in here. We're going to cheat and we're going to use that, and then we need the yellow, which is this one here. So now when we flip this, we should have continuity. There we go. If I can hold that in there, and then we switch it. There we go. So the switch on the side for reversing the direction of the fan is also good. So there we checked all three components in here, and all of them are good. So that moves us over to the motor itself for being something wrong. So let me put this switch back in here. Alright, so we're all set here. So we can actually set this part aside because this is okay. And remember, the lights were always okay. The lights always worked. So I'm going to set this over here for right now. And now here is what we got to look at. So I'm going to actually take this off our little plug-in thing because we can't use this unless we have our switches connected. So let's just throw this aside. So we have these wires coming out, we have a ground here, all these wires connected. So now we're going to have to take this apart to see where the wires are going to the motor and see maybe there's a fuse inside the windings. Now I looked at a fan a while back. I don't remember exactly which one it was. I think it was a little floor fan or something, and the windings had a fusible link, I guess you'd say, connected through the main power wire, which would be our black, and it goes through that and it sits on the windings, and if it gets too hot then it blows the fuse. So it goes through that and then out here to power everything else. So let's see if there's one of those in here. We'll look at that next. All right, let me get to taking this apart. We got screws on both sides. There we go. A little wiggling. So actually this side came out first. This side didn't come off yet. So this is what we got on the inside. Looks nice, don't look like anything wrong with that. Here's our little piece that those three screws were screwed into, and then it let go when I took the screws out. So that ought to be fun putting it back in there. Let's look and see what we have over here. Here we can see the other wires. Let me see if I can get a picture in there, a good view. Yeah, there you go. You see the wires in there that are coming back out here, and they go to all the windings. Oh, that looks like it might be burnt a little bit. Why is that? And that's the red wire. Not sure where that went into. If that's the same red wire that comes out there, it connects to this red wire that goes to the capacitor. Let's see, it goes in that corner. This thing goes here. Yep. So that red wire goes to the capacitor. Quite the mess. Let me pick a little bit at it. Oh, that just green junk just fell right off. Yeah, right there. Let's see if I lift that wire up. Look at that. The wire's not even connected. It burnt right up. So that would be the right reason why we're not working. That wire right there is not connected. You can see it burnt up that whole thing. It actually burnt up while it was over the top of one of these. So it pretty much destroyed the coating that's on these windings to prevent them from shorting out when they're wrapped together like this. So yeah, that's gonna be a no fix for the, oh, look at that. That one just fell off too. I just went to pick it up, and the corrosion, you can see the corrosion right on there. Yeah, there's the other half of the wire. So yeah, this looks like, definitely looks like it's not going to be fixable. I was hoping it was going to be, but yeah, with all that, with that getting hot, the insulation around the wires is just cracking to pieces. I mean, it must have got really hot, and it started melting. It melted this plastic shield right here that I just broke. And you can see here's another part of the wire I just broke off. But yeah, all this green stuff is actually right on the windings. So yeah, that's definitely not going to be good, because it melted the coating that's on the windings there. And same as this one over here. It's got the green slime or whatever it is all over the windings on this side too. So yeah, it definitely heated that stuff up and toasted those wires. So that's gonna be a no fix. Sorry, not this time. And you know, and I'm not one to go ahead and wind all this up again. That would never happen. Factory does that stuff. All right, sorry that we couldn't get the rest of this fixed, but at least this video was somewhat helpful with checking all the other components. And this doesn't have what I was looking for, a thermal fuse, because if it did, it would probably be right in this area right here. So yeah, it just burnt up the wiring and ruined the windings. It's all right. There's nothing we can do. Darn. And I was hoping so hard. All right, that's it. This goes in the junk pile, and we shall see you in the next one.